Good day. The topic of our research is intelligent system for processing and forecasting financial assets and risks. Problem statement. In the modern world, where data volumes are constantly growing, the importance of accurate accounting and forecasting of financial indicators becomes particularly significant. The relevance in this field primarily lies in the increasing need for precise and efficient tools capable of automating operational and analytical actions of data from financial flows, taking into account the risks of incorrect investments. In the context of formalizing the process of processing data from financial flows or indicators, it should be noted that their nature can vary. Specifically, data from the outset may be well structured, semi-structured, or unstructured. Structured financial data have a clearly defined format, often adhering to a relational database model characterized by a standard hierarchical order. Semi-structured financial data are often not stored in relational databases like structured data, but possesses certain organization properties that facilitate their analysis. So various methodologies are used for forecasting financial data and creating client profiles, typically based on the analysis of historical data and influencing factors. This involves establishing statistical relationships between different characteristics and developing predictive models. Previously, the single factor forecasting methods were dominant, relying on time series and regression analysis. However, not all of these approaches are sufficiently effective for assessing financial indicators and investment potential. In general, when we study the different literature resources, the process of accounting and forecasting finances is accompanied by a series of challenges, among which the following can be highlighted. First of all, is the high unpredictability of the external environment. Secondary is income variability. This variability complicates forecasting and requires a more flexible approach to budgeting and financial planning. Behavioral factors and economical and market conditions. All these problems can be researched and are relevant to our concept. The project concept proposal based on ARIMA. Within the research, in addition, in development of software logic for web application for financial data accounts, is the creation of hybrid polynomial regression machine learning models for data forecasting will be conducted based on ARIMA. ARIMA represents a unique combination of autoregressive model and moving average models. The advantage of this approach is the ability to use such models for automating and forecasting of time series values, in our case values of financial assets and risks based on their past values, taking into account and obtained error estimates from previous forecasts, providing the models with a higher degree of adaptivity. And we can see in these formulas the specifics of autocorrelation function and autocorrelation partial function. With ARIMA, we can see in this slide. The detailed scheme of the web application's operational stages is provided on this slide. We can see data accounting, bank statement in formats CSV, comma separated value, transaction import module, converting records from comma separated values files into transaction entities, records to database, relation database, displaying transactions in a general list, and launching the process of forecasting financial risks with the specific parameters, saving results to database. In this slide, we can see the sequence diagram of user actions in the development software. And we can see user can start system with transaction import form. Then after it comes to transaction import and migration model, transaction display model, risk forecast generation model, and machine learning models which are chosen and used for forecasting and updating with structured data. And after that, in the user interface, we have some forms and components which helps us to visualize report data and forecast data. The next one is the pages, is the scheme of system interface pages. We can see that the application has a verification page, system authorization form, and registration form, main user interface form, accounting pages, analytical pages, and report generation pages. Some specific page is transaction management page. We can use this page for make sure that all transactions are correctly provided. Experiments and results. In this slide, we can see the autocorrelation and partial autocorrelation plots that describes the dynamics of using the ARIMA model to provide risks evaluation and research statements discussion in such dependencies. We can see also on this slide mean average error metrics, which we used to combine and see the difference between ARIMA model, profit models, and XGBoost model. And we can see that it should be noted that the overall nature of the distribution is the obtained evaluation results for autocorrelation function and other models is quite balanced, with the spread not exceed values about 0.25 on the positive side and 0.075 on the negative side. The data sample is uniform, resulting in financial risk values changing from about less than 1%. As can be seen, the lowest middle average error value around 400 and half is achieved by XGBoost model. However, the computational time of this model is nearly 3 times greater than the hybrid ARIMA-based model, which has a middle square error of over 610. As a conclusion, we can see that we developed the software which can be used for making research with financial risks assessment and assets based on a different models such as ARIMA model, XGBoost model, and profit model. Software capable of automated processing, tracking, and forecasting financial assets and risks with hybrid machine learning models. The research involved exploring models for time series analysis and regression models with the context on predicting expenses and profits based on a prepared data set of user transactions over a 3 years period from open resource. Middle average error metrics for each model are presented to aid in selecting the best performing model for further performance enhancement. Considering the chosen algorithm, it's advisable to further calculate the weight values or factors and dynamically adjust the hyperparameters of great hybrid ARIMA model to increase its productivity and accuracy. An optimizing model can be used for more precise forecasting of user spending and profit risks. It's worth noting that obtaining predictive values of financial risks, taking into account user behavioral factors within the investment strategy, enables a clearer and more predictable assessment of profits. Predicting expenses for stable profits is less relevant. A subsequent step in algorithm research involves testing the model on different data sets, such as the data from different users. Thank you for your attention.